So as promised in the previous videos, I'm going to give a brief introduction to inequalities by looking at them on a number line. I'm then going to go back to the examples I covered in the video on errors in rounding and write inequalities for the range of values that we drew on a number line. So in this video we're going to understand what the symbols mean for inequalities and identify the range of values from an inequality by drawing them on a number line. So here are the symbols for inequalities. This symbol means greater than. This symbol means greater than or equal to. This symbol means less than, and this symbol means less than or equal to. So let's just say we had x is greater than 5. Now, when looking at inequalities, we generally use a letter, usually the letter x, to represent possible values. But you can use other letters. Now, x is what we call the variable because it represents a range of possible values. So this means that x is greater than 5, or we can write it like this: 5 is less than x. And here's how it would look on a number line. So there's 5, and we're interested in the infinite range of values that are greater than 5. And because it is x is greater than 5, 5 is not included in this range of values. Let's say we had x is greater than or equal to 10. Or we could say that 10 is less than or equal to x. So here's 10 on a number line. And here's the infinite range of possible values for x here. This time, 10 is included in this range because it says x is greater than or equal to 10. And if we look at this one here, x is less than minus 1, or we could say that minus 1 is greater than x. So here's minus 1 on a number line, and so x is the infinite range of values here, and minus 1 is not included in that range. Now let's concern ourselves with a range of values using inequalities, but this time using two limits. So let's say we have something like this. To understand what this inequality is saying, let's divide it up. So the first bit we have is 1 is less than x, which also means that x is greater than 1. And we also have x is less than or equal to 6. So we would say with this inequality that x is greater than 1 and is less than or equal to 6. So let's put this on a number line. So here's 1 and here's 6. So our range of values is between these two limits. But in the case of 1 actually isn't included in that range. And so what we do is we put a circle that hasn't been filled in. And for 6, well, 6 is included in this range of values. And so this time we use a circle which is filled in. So that's how this inequality is represented on a number line. Let's try another one. Again, let's break the inequality up. So we have minus 5 is less than or equal to x, which means that x is greater than or equal to minus 5. And we also have that x is less than 10. So this inequality is saying x is greater than or equal to minus 5 and less than 10. So let's put our limits on a number line. Here's minus 5 and here's 10. And our range is between these two limits. This time, minus 5 is included in this range of values. So we put in a filled-in circle like so. But 10 is not included in this range. So we draw a circle that isn't filled in. So here's a number line with a range drawn on it. What's the inequality for that range? So we have the limits 1 and 15, but for this lower limit, we have x is greater than or equal to 1 because the circle has been filled in. And for the upper limit of 15, we have x is less than 15 because the circle hasn't been filled in. So the inequality is going to look like this. And this inequality is saying x is greater than or equal to 1 and is less than 15. And if we were writing the inequality for this range, well, we have our limits -3 and +3. So our lower limit, x is greater than -3 because the circle hasn't been filled in. And for our upper limit of 3, x is less than or equal to 3 because the circle has been filled in. So there's our inequality. X is greater than -3 and is less than or equal to 3. Let's go back to the examples we covered in the lesson on errors in rounding and have a look at the range of values that we drew on the timelines. Here they are. I'm going to go through these, but you might want to pause the video and have a go yourself, and then press play when you are ready. So in this first example, we have our limits of 45 and 55. Our lower limit, x is greater than or equal to 45, which would mean that 45 is less than or equal to x. And our upper limit is less than 55, which would mean 55 is greater than x. And so our inequality looks like this, where x is greater than or equal to 45 and less than 55. In the next example, our upper and lower limits are 6.5 and 7.5. And our lower limit is x is greater than or equal to 6.5, and our upper limit is x is less than 7.5. So we have our inequality looking like this. Now, if you've already written the inequalities for these ranges, you've probably noticed that all the lower limits are less than or equal to x, and all the upper limits are greater than x. And this is to do with the nature of rounding. So let's continue with the examples. Here's the next one. So we have our limits of 8.35 and 8.45. For our lower limit, x is greater than or equal to 8.35, and for the upper limit, x is less than 8.45. And here's how the inequality will look. And here's the next example. So we have our limits of 1,650 and 1,750. So our lower limit is x is greater than or equal to 1,650, and our upper limit is x is less than 1,750. And here's the inequality. And the next example, our limits are 315 and 325. So our lower limit is x is greater than or equal to 315, and our upper limit is x is less than 325. So here's the inequality. And the next one. So we have x is greater than or equal to 450, and x is less than 550. So here's the inequality. And finally, we have x is greater than or equal to 12.5, and x is less than 13.5. And here's the inequality. So there's a brief introduction to inequalities by using them to identify a range of values on a number line. I hope you found the video helpful, and thank you for watching.